Hello everyone, my name is Anita and welcome to my YouTube channel. Today in this video we will see how to implement the feed-forward neural network with Keras and TensorFlow on the MNIST dataset. So make sure you are watching this video till the end. So let's get started. So these are the steps that we want to perform on the MNIST dataset. So that is given in the problem statement. So basically these are the steps that we are using for building any deep learning model. So the first step is import the necessary libraries. So here we are importing the TensorFlow, and from TensorFlow we are importing the Keras. So TensorFlow is an open source free library used for the neural network, and the Keras is a user friendly neural network library written in the Python. So these two libraries we are importing. After that we are importing pandas as a PD, we are importing numpy as a NP. After that we are importing matplotlib.pyplot as a PLT. For visualization purpose we are using this. So this is the first steps. So after this the second step is what? Loading and preparing the data. So these second steps we are dividing into the two. That is, first is the loading the data. So for any model, the first step is to read the data that we will be using as an input. So here we will be using the MNIST dataset. So first let us understand what is that MNIST dataset. So MNIST stands for Modified National Institute of Standard and Technology. So it is a data set. Basically this is the digital handwritten data set. It contains 70,000 handwritten images, and each image is of 28 by 28 pixel. That is about the 784 features. Each feature represents only one pixel intensity, that is from the 0 to 255, and this database is further divided into the training and testing dataset. So training contains 60,000 records and the testing contains 10,000 testing images. So this is how that MNIST dataset. Now what I want to import that data set. So here we are using the Keras library. So we are using tf.keras.dataset.mnist. So Keras library, this MNIST dataset is already there in the Keras. It is by default, it is present. So we are we are importing this into the MNIST dataset. After that, MNIST.load underscore data method returns the training data and the testing data. After loading our data, we are dividing or splitting the data into the training data and the testing data. So here we are splitting our data. So I just want to see what is the length of my training data set. So I have written length of that extrain. So you can see here 60,000 is the value. After that I want to see the length of the testing data set. So 10,000 is the length. Uh, After that, what I want to read the shape of my data set. So extrain dot shape. So you can see here the 60,000 comma 28 comma 28. This means that there are 60,000 images in the training set, and each image is of size 28 by 28 pixel. So same is for the testing data set. You can see x underscore test dot shape. So 10,000 is the size, and again it is 28 by 28. Now what I want to see the first image, or how that first image looks like. So here I have used explain of 0. That means it's showing me the image of matrix. You can see this is the matrix of size 28 by 28. That is, it contain total 784 feature, and each represent the intensity, and that intensity is from the 0 to 255. You can see here all these are the intensities of that image. Now I want to visualize that image. So I have just used that matShow method is used to display the data as an image. So this is the image that is there in that 0th position. the second step. So here up to this point I have loaded my data. Now what I want to pre-process the data. So in pre-processing, what I am doing, I am normalizing the data. So before feeding the data to the network, so we will normalize it. So why we are normalizing it? So normalizing means we are like scaling the pixel intensity to the range of zeros and one. So normalizing the input data, it helps to speed up the training. Also, it reduces the chance of getting stuck in the local optima. Since we are using the stochastic gradient descent to find the optimal weight for the network, so that's why we will normalize our data. So here how we are normalizing. So you can see here at extrain data, we are dividing each value by the maximum intensity of 255. So here each value we are taking and we are dividing by the maximum intensity, that is 255. So this is how we are normalizing the data. And after normalizing, again I want to see the first image. So you can see here, this is the matrix containing zeros, all the values between zeros and 1. So this is how we have normalized the data. After that, the next step is what? Creating the model. So again, there are the three ways to create the model in Keras. So here we are using the sequential method or the sequential method. So why we are using that sequential? So sequential, it allow us to build the model layer by layer, and this sequential method is used to create a layer of network in a sequence, that means one after the another. So you can see in sequential model, again I want to create a model in a sequential form. So again in these three layers are there. So first layer is the input layer, the second layer is the dense layer, and the third one is the output layer. So these three layers are present in my neural network model. So the first layer, that is in the input layer, we feed the image. So here you can see that we are feeding the image of 28 by 28. That image is of size 28 by 28. So actually here we are giving the input as the two-dimensional image, that is 28 by 28. So we have to use the flatten method to compress that input. That means what we are doing here, we are basically reshaping the 28 by 28 pixel image, that is two-dimensional image, into the 784 values or into the one dimensional. So basically we are reshaping the data from 2D to 1D. So that's why we are flattening, we are using that flatten method. So this we are doing after the first steps. What we are doing, so next we are using the dense layer, or the dense method is the another layer. So what is that dense? So this dense ensure that each neuron in the previous layer is connected to the every neuron in the next layer. Okay, so here whatever input we are getting from the first layer, that is we are getting the 784 values. So that is passed to the 128 neuron. So this 128 is the neuron with we are using the ReLU activation function. So ReLU is what? It is a rectified linear unit. So mathematically you can see the function is y is equal to max of 0 comma x. So this function, this activation function is used in the hidden layer. So good thing about is that its gradient is always equal to 1. So this way we pass the maximum amount of error through the network during the back propagation. So that's why we are using ReLU in the hidden layer. After that the third layer is the output layer. So this output layer containing the value 10. So 10 is the neuron, 10 neurons. So why 10 we are using? For each class, here actually there are 10 classes are there. So that is for each class from 0 to 9, and we are using the activation function as a softmax activation function. So this softmax activation function is used as a on the output layer to turn the output into the probability like values. So since we have here the 10 output classes, for each class probability will be sent as an output between the 0 to 1. So all neuron will output the probability and the one with maximum probability will be picked up. For example, suppose the output is 5. 5. So neuron number 5 gives the output the maximum probability and that will be selected as an output. So this is how that softmax activation function work. So here we have created the model. Now I want to see how my model is created. So with the help of model.summary, we will see the how the model is generated. So you can see the first layer is the flattened layer giving the 784. After that the dense layer containing 128 neuron and the last is the output layer containing the 10 neurons. So this is how my network is generated. After that, after constructing or creating that neural network, I want to compile it. So for compiling, again it takes the 3 parameters. So the first parameter is the optimizer, second one is the loss, and the third one is the matrix. So here you can see that I have used the optimizer SGD, that is stochastic gradient descent optimizer. So this optimizer control the learning rate. So we are using stochastic gradient descent as our optimizer. So we have used after that we have used the sparse categorical cross entropy as our loss function. So why we are using this? Because it saves the time in memory as well as the computation. So since it simply uses a single integer for a class rather than the whole vector, and it lower the score indicates the that model is performing the better. So that's why we are using that sparse categorical cross entropy. After that, the third parameter is the matrix. So in order to determine the accuracy, we will use the accuracy matrix. So to see the accuracy score on the validation set when we train the model. So that's why we use this metric. After that, the next step is, after compiling, the next step is to train the model. So we will train the model with the help of fit method. So here you can see model.fit method function we are using. So it will use the parameter. You can see it will use the parameter as the training data and the number of epochs and the validation data. So in validation, we are passing the X test and Y test. And here we are using the epoch equal to 10. So what is that epoch? So the number of epoch, you can see here the number of epoch is the number of time the model will cycle through the data, or the more the epoch we run, the more the model will improve up to a certain point. And we repeat this process of going through the whole data set. How many times? So 10 times. So that's why my epoch value is 10. So you can see after training the model, you can see that here all that whatever, like after training the model, I have saved that into the history variable or the history object. So you can see for the first epoch my model accuracy is less, like 84%, and the loss is 63%. As the epoch value is increases, so model accuracy is increases. You can see 90%, after that 91, and it goes on, it increases. So at last you can see 10 by 10. So my model accuracy is increases and loss is like minimum 0.16. 16% is the loss and the accuracy is 95%. So this is how we have trained the model. Now after training, I want to evaluate that model. So we are evaluating with the help of model.evaluate method, and for that method we are passing the test data or the testing data set or the validation data set we are passing. So here you can see that it computes, this method computes the loss, test loss and test accuracy it will compute. And the metric defined when compiling the model. So in our case, the accuracy is computed on the 10,000 testing data. So after evaluating the model, we will now check the model for the testing section. So here you can see that now what I want to check, or I want to make the prediction on the new data set. So for generating the new data, I have manually taking the data. Random value I have take manually, that is there in the n variable, and that n I am passing to my test variable. And here you can see the 4 is there in my test value, test x test of n. Now I want to check the performance, how my model is performing. So I am using that model.predict method. So here you can see that model.predict method is used to do the prediction on the testing set, and that value, whatever value is there, we are storing into the predicted value. So now what I want to print that, or I want to print that value. So here we are using that np.argument max. So it return the indices of maximum value along an axis. So here whatever value is there, so from that it will return the maximum value, and that value is what? The 4. So the handwritten number in the image is the 4. So this is how you can see the output is predicting. Now you can see here we have successfully predicted the correct output, because our accuracy is the 95% accuracy. Now we are getting. So now what I want after this, I want to plot the graph for the accuracy and the loss. So when I have trained my model, here you can see that all whatever is there, so I have stored into the history. So one of the default callback registered when training all the deep learning model is the history callback. So it record the training metrics for each epoch, and this include the loss and accuracy. So this history contain all the all the metrics, we can say, for each epoch. So you can see this history contain all this value, that is value, loss, accuracy, all these values that are there in the history. So history object is written from this call of the fit function used to train the model. So the metrics are stored in the dictionary. So here you can see that I want to see that what is there in that history. So after running this step, you can see that all the history, it contains that the what we can say, the accuracy and the loss values are there. So first is the loss value, and the second one is the accuracy value. So the 10 loss values are there, and 10 accuracy values are there. So this is actually the dictionary. So basically it is in the dictionary format. So here we are using epoch equal to 10. So it 10 times it is showing all the loss and the accuracy values. So here you can see that what I am using, I want to see that what is there in that dictionary. So it is basically the format is dictionary. So I want to see the key. So you can see that dictionary key is loss and accuracy, and value loss and value accuracy. So this loss, first loss is for the training loss, and the first accuracy is the training accuracy. Value loss is the validation data loss, and this value accuracy is the testing data. So this is how we are getting all the loss and the accuracy values in that history object. So now what I want to do, I want to plot that. So here I want to plot the graph like this. So here I am using plt.plot history accuracy. So from that I am getting that all the 10 values of the accuracy, and here you can see that plt.plot history.value accuracy. So all both values, so both testing accuracy and the training accuracy I am getting, and I am plotting it on the axis. And here this we are using plt.title for giving the title as the model accuracy. Y label, on Y label I am giving accuracy as the label, and on X label I am giving the epoch, and this is the legend I am using, that is train and validation, and here the location of that legend is low upper left corner, and here I am using plt.show. So you can see that this is the model accuracy graph. After same I want to plot for the model loss. So only what I am using From that dictionary, history dictionary, I'm taking all the 10 loss values and I'm plotting here. So you can see here, this is what the loss. So again, what I want to like plot the graph combinedly, like training loss and the training accuracy. So that's why I'm using all these things like combine. I have plotted, and you can see that. So from this you can see the conclusion is what. So with the above code we can see that throughout the epoch our model accuracy is increases. So you can see here that blue line is what our accuracy, and that orange line is the value accuracy. So value accuracy is nothing but what, testing accuracy. So as you can see that model accuracy is increases and our model loss is decreases. So that is good, since our model gain confidence with its prediction. So again, here the two inferences I have drawn from this. So the two losses, that is loss and value loss, you can see here green is the loss and red is the value loss, are decreasing, and the accuracy. So accuracy, again the two accuracy, that is the accuracy and value accuracy are increasing. So this indicate that model is trained in a good way. And the second conclusion is what? The value accuracy is the measure of how good the prediction of your model are. So in this case, it looks like the model is well trained. After how many epoch? After 10 epoch. So this is how we have like drawn the inferences from this graph. So this is how the assignment have done. Now after this, suppose you want to save the model. So if you want to save the model, so here you can see I have used one variable name and I have given the path, and after that I have used model.save, and here the path is given. So on that location the model is saved. After that, like suppose if you want to run the model after few days, so then we will have to run the whole code again, and which is the time consuming. So in this case what we are doing, like we have like saved the model already, so we are like only loading that saves model with the help of this code. So you can see here, use the same code. So tf.keras.model load model. So this is my model name, so that I am only using and loading that, and current using that model for again for the running the next time. So it will save our time. So this is how the assignment is implemented, that is feed forward neural network with the Keras and TensorFlow on the MNIST Dataset. So I hope you like this particular video. So please do subscribe my channel if you have not already done, and share this video with your friends. Thank you.